Now we are going to see about PySpark. So to do PySpark, we have to first install PySpark and ML extent. So here we are using RDDS, data frames, NumPy and SkyPy, linear regression and clustering and mining and so on. So we are using this so that we have to import all this section which we have using there. So now we are going to see about RDDS. Basically, RDDS means resilient distributed datasets. It is a distributed collection of elements that can be processed in parallel. It is Spark's core data structure. So in that, we are given the input as 1, 2, 3, 4, 5, and we are printing that collect, which means what we have given, it will brings all the RDD elements to the driver. So we will get the output as 1, 2, 3, 4, 5, and RDD map x into 2 means it will multiply the given value what we have given in the as a input, like x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5. So 1 into 2, 2, 2 into 2, 4, like that we'll get the values. Now we are going to see about data frames. Basically, data frames is a distributed collection of rows and columns with schema. It is like database. It supports SQL like operations. Now we have given data as 1 Alice 23, 2 Bob 33, Charlie 25. These are the data which we have mentioned below, like ID, name, age. So here we have printing like df.show, which means we have given the data, it will shows what we have given, like so df.filter df.age greater than 24 dot show means it shows the data where the peoples have age more than 24. So that's why we are getting this 2, 3, Bob, Charlie, 30, 25. See, here we are getting more than 25 age. That's why we are using data frames. Now we are going to see about NumPy and SkyPy. Actually, NumPy is like a numerical data. First, we have to give an array as 1, 2, 3, 4, 5, and we have to find the mean. So it plus all the values and divide by the total number of values. That's why we are getting mean value, and it finds the standard value. Now we are going to see about SkyPy. Actually, SkyPy is a statistical tools. So it is used to statistics the data. So from here we are using sample one as 1, 2, 3, 4, 5 and sample two as a 3, 4, 5, 6. So here please dot means it shows the sample mean greater than mean two, and p-val means it is difference is not significant. So we'll get the value as -1, 0.3 and so. Now we are going to see about linear regression. Actually, basically linear regression is like we are using the y equal to mx plus c to find the best data. It is used to predict the continuous values. So now we are giving that train data equal to 1, 2.0, 2, 4.0, and so on. So the linear regression coefficient is 2 is to 1. Intercept is 0.0. So data fits perfectly, that we have to multiply the values, label equal to 2 into feature. So the value is coefficient is 2 and the intercept is 0. So if we substitute in the equation y equal to 2x, we will get the value as 0. So now we are going to see about clustering. Actually, clustering is also known as k-means. It is a group of data into k clusters by minimizing distance to cluster centers. So here we are giving the data as this 0.0, 0.0 and 0.1 and 0.1, 9.0 and 9.1. So here clustering means two natural groups in data. It takes an average data. So that's why we are getting this. This is an average data. And now we are going to see about association rule mining. It is also known as FP growth. So here we are giving that 0, 1, 2, 3 as milk, bread, butter, milk, bread, butter, and so on. So it is known as it finds the frequent item sets and generates rules like if A is bought, B is also bought likely. So here that we are seeing that we are getting milk three times here, and bread we are getting four times, and butter we are repeating three times, and milk bread we are repeating three times, and bread butter we are repeating three times. So according to association rules, milk and bread, it is confidence, so we are getting 1, and bread and butter confidence we are getting 0.75. Like here milk appears three times and bread four times. So milk plus bread appears together three times. So the rule is milk and bread has confidence 3 by 3 equal to 1. So like that rule, bread and butter has confidence 3 by 4. That's why we are getting 0.75. 0.75 and 0 1. So now we are going to see about decision tree classifier. Actually, in tree, like decision tree means it splits the data into branches based on feature conditions to classify the labels. So here we are getting the data as this, and we are mentioning the data frames as feature 1, feature 2, and label. So in feature 1 equal to 0. So feature 1 we are considering as label 0, and the feature 2 is considered as label 1. So the 3 stops at depth 1 because it splits it perfect. So the decision tree classification model of depth 1 with 3 nodes. So we are getting one planned with 3 nodes, like example. So if feature 0 greater than 0.5, it predict as 0. Else, if 0 greater than 0.5, it predicts as 1. So this is our decision tree classifier.